Starting with this lesson, we're going to start looking into the topic of solving equations. So first of all, what is the definition of an equation? Well, an equation is just two mathematical expressions that are set equal to each other. So in section 3.3, we looked at lots of expressions and we simplified those expressions. But if you have two of those expressions set equal to each other, that's called an equation. Now, so what does it mean to solve an equation? Well, remember with mathematical expressions, there are variables involved. So to solve an equation means that we're going to find what the variable should be equal to so that the left side of the equation equals the right side. All right? That's literally what solving an equation means. All right? Now we're going to start real basic with equations that look like these here, where we have a variable and either minus a number or plus a number equals another number. All right, so this is about as basic as we can get to start with. And looking at this first example, you can probably just see what this variable should be so the left equals the right. You can probably just look at it and say, hey, x should be 16, right? Because 16 minus 5 is 11, okay? But obviously, not all equations are going to be quite so simple. So we need to come up with a process for solving an equation. And so what we use is the addition property of equality in this situation. Okay? So if you have one expression equal to another, so you know that A and B are equal, then if you add the same thing on both sides of that equal sign, you still haven't changed the fact that the left equals the right. Okay, so this and this are what we call equivalent equations. All right, and then same thing with subtracting. Since subtracting is the same as adding the opposite, it also holds for subtraction. So if you know A equals B, then A minus C will equal B minus C. All right. So this is how we're going to solve these things. Is what we want to do is we want to make it so that in the end we just have x equals a number, because then we would know exactly what x should be. So as long as this equation up here is equivalent to this equation down here, then my value of x won't have changed, and we'll know exactly what it should be. So since I'm subtracting 5, and I want x to be all by itself on the left side, what we're going to do is we're going to add 5 to the left side, but that's only legal if we also add 5 to the right side. Okay, so we have negative 5 plus 5 is 0. Okay, so again, we're thinking of a minus and a negative kind of interchangeably. So what we have is x plus 0, because negative 5 plus 5 is 0, equals 11 plus 5 is 16. And of course, we know x plus 0 is just x. Okay, normally I don't need you to show this, but I'm just proving a point that negative 5 plus 5, what we're just going to do is add the opposite of what we have there. All right, so x equals 16 is our solution. Okay. Over in this example, we have y plus 13 equals 17. So we have a positive 13 here. So the opposite of positive 13 is negative 13. So you could either think of this as adding negative 13 or adding the opposite, or subtracting 13 would do the same thing. So as long as I do that to both sides, I end up with nothing except y on the left side, and then 17 minus 13 is 4. And I can check my work. If I put 4 in here, 4 plus 13 is going to equal 17. Okay. So one way to kind of understand this whole thing is to kind of think of a scale. All right, so, an old-fashioned scale, not the digital ones that we stand on. So, at first over here we had x minus 5, and since x minus 5 was equal to 11, the scale was completely balanced. Now, when I added 5 to the left side, that brings this side of the scale down, right? It would have pushed it down. And so we need to keep the scale balanced, and so that's why I added 5 to this side as well to balance it out once again, right? And so that's how I can be confident that, yes, x equals 16 is my answer, because my scale is still balanced.